Oscar, Carlos, José Miguel, María José, Chelsea, Sofía, Santiago, Sebastián, Bruno, Rodrigo, aquí, Joel, Paulo, Andrea, Marcelo, Joana, Helga, Paola, Sofía Miel, Mariano, María Isabel, Rafael, Daniel, Okay. Fine, ready? Okay, we're going to continue with limits today, but today we're going to see how to find a limit, how to solve it using numbers numerically. If you remember from yesterday, as an introduction, places, to remember yesterday's topic. For example, imagine that we have a graph such as this one, the function f of x. If I want to find the limit of the function as x approaches c from the left side, what does it mean? Okay. Okay, let me do it so you can understand what I mean. In this case, for example, if I say the limit of the function x approaches c from the left, because of the little minus, it means that I'm approaching the value c just from the left side in the x-axis, and then I'm looking what happens to the graph as I approach that value. So in this case, this answer is that value. We're going to call it f of c. If I want to do the same, but approaching from the right side of the value c, now it's the other direction. You approach from the right, so you approach from the right of that value to get a certain answer, which in this case is going to be also f of c. And if I say that I want to approach from both sides at the same time, what do I mean? Exactly. Left and right at the same time. So you approach that, which in this case is the value, again, let's call it f of c. Okay? That's what we did yesterday and the class before. Also, if you remember, if from the left you get to a certain value, from the right you get to the same value, what happens? The one that is the full limit has that value. The same. But if those two are different, what happens with the full limit? It doesn't exist. Very good. Okay? Do you get that? Okay, very good. So the idea for today is that we're going to solve limits now, but without graphing, using numbers. Okay? So if I want to solve a limit without looking at the graph, by using numbers, we're going to evaluate. But we're going to evaluate using numbers that are as close as possible to the value c, without touching the c, and then observe the tendency of the values. Okay? Do you finish copying that? No? Okay, I'll go ahead. Good. Let's continue, please. Example. Let's say that I want to solve this limit. Limit x approaches 2 of the function x plus 1. Okay? I want to solve that limit without numerically, okay? Without graphing. The function here is already defined. So instead of having just f of x, now I have x plus 1. It's a linear function. So if I want to solve this numerically, what do I need to do? What I'm going to do is this. I'm going to give values to x. And substitute in the function to get a value. So for example, if it says limit x approaches 2, that means that I'm going to give values to x as close as possible to 2. I have the 2 here, but for example, what could be a value that is close to 2 without being 2? Even closer. 1.9. 1.9 could be 1, or another one could be 2.1. Even closer, 1.99, for example, 2.01 from the other side. Or perhaps 1.999 or 2.001. Don't need to give as many values, but in this case I'm just giving that as an example. Okay? So the idea here is that if you observe we're getting close to 2, let's evaluate in the function to see what happens. So for example, if I put 1.9 in my function, 1.9 plus 1 is what? 2.9. 2.1 plus 1? 3.1. 1.99 plus 1? 2.99. 3.01. 2.999. 3.001. So, as you observe, my tendency of the function is that it's going towards what value?
2.
3. 3.
Oh, yeah, that's true.
Okay? So that is going to be my answer to the limit. That is going to be towards the 3. Okay? Usually the idea is that we're approaching a value. So the answer is going to be most of the times an integer number. We're approaching it. Okay? That's a tendency of the function. Do you understand that? Yeah. We're going to do more examples. Huh? If you observe, if for example I use the same value 2, the answer is going to be the same, 3. That's fine. But what would happen if I have a function that for any reason the exact value doesn't exist, but there's a tendency? Example. Let's say that I want to find the limit as x approaches 0, but just from one side. Let's say the right side of the function 1 over x. What values of x do I need to give to that? If it's 0 from the right. Only positive ones. So, what could be a possible value? 1. Even closer. 0.1. Closer than that. 0.01. Even closer. 0.001. And so on. Okay? Until you have the 0. So, if I evaluate, then it will be 1 over 0.1. How much is that? You can use a calculator as well. 1.1. Ah? How much is 1 over 0.1? 10. If I divide 1 over 0.01 instead, will be 100. 1 over 0.001 will be 1,000. Okay? But if I were to evaluate at 0 directly, what would be the answer? 1 over 0 is what? No, it's 0. It's undefined. Doesn't exist. So, think a little. What would be the answer then? My function is approaching what? What number is it approaching? No. Infinity. Huh? Infinity. Why infinity? Because if my values that I use are closer to 0, my y values are getting bigger. Okay? Even though at the end the exact 0 doesn't exist, doesn't matter. I'm approaching 0. I'm approaching infinity. So the answer to that limit is going to be infinity. Okay? Do you understand that? If you still don't see it right now, let's try graphing that. What would be the graph for that? Remember, for matrix, what's the graph of 1 over x?
Racional.
It's a rational function, yeah? But what's the shape of the graph? That's fine. If you forget, fine. But you need to study, yeah? Because it's going to be an activity and also in the next quiz. So, if I want to graph 1 over x, it's a rational function, and the shape of that is almost something like this. This and like this. Remember that?
Yes.
And if you remember, we have asymptotes. We have a vertical asymptote at x equal to 0, and horizontal asymptote at y equal to 0. Now, checking the graph. In this case, what it says is that I'm approaching the 0 in x from the right side, but 0 from the right. My graph is going towards what? Okay. Yeah? So this complies with this.
Let's go.
Questions?
Profe, ¿vamos a graficarlas de eso o graficar?
Eventually, yeah.
No, ni eso.
Not in this activity,
Ya,
but in the quiz, yeah.
tenemos que saber cuándo es el que inició la serie.
Miren, si ahorita todavía no se acuerdan, les olvidaron las racionales o que las exponenciales y logarítmicas, también hay una actividad que van a hacer mañana en Lago, viernes, sábado y domingo. Una actividad precisamente para eso, para que repasen. Que hay 5 intentos, el de lunes, ¿se acuerdan? Hay 5 intentos, todo eso. Es una que repasen, porque ya el siguiente quiz, que es el viernes que sigue, seguramente van a tener que graficar algo de esto. Y si no se acuerdan de nada, pues van a sus orillas, por favor. Y con gusto los ayudo ahí.
En la gráfica, el que no existe, ¿dónde se ve reflejado?
In the asymptote.
Pero la imagino que está así, pero entonces la F es todo el valor de la Y. ¿Cuánto te consigues al decir
Okay, no, remember. For example, here, what this means is that I'm evaluating the function with values that are very, very close to 0. For example, if I want to represent this in this graph, it means that, for example, let's say that this is the point 1, so the answer is this value. Then closer, 0.01, so the answer is that value. 0.001, so the answer is that value. But when I put the exact value 0, there's nothing in an answer. But if I keep giving values that are closer and closer and closer to the 0, without being 0, the graph is all the way up. That's what this represents.
En las racionales, en la cinta vertical siempre va a ser igual. O si cambia con las transformaciones.
Changes the transformation. This one doesn't have transformation, not right now. But yeah, if I were to have, for example, x plus 3 as the denominator, then it would. Okay, another example. Can I read this? Yes. Okay, something a little more complicated. For example, let's say I have the limit x approaches 3, but this time from the left, of x squared minus 9 over x minus 3. That's a more complicated function, but still, it's not that hard to do.
Tenemos que hacer de dos.
Easy.
I have two values for both. Okay. Values for x. Which ones? 1. No, 1.
No, 2.9.
But 2.9,
2.99.
2.99, or 2.9999. Okay, and the 3. See what happens. Then we're going to evaluate. Help me with this, please. If I want to evaluate 2.9 in this function, what will be the value? Help me with the calculator, please.
8.41.
8. Too much, no?
Ah, sí, because I didn't do the minus.
No, should be more like 5 point something.
5.9.
5.9?
No, 0.59.
No, 5.9.
¿Qué pasa?
No podemos presionar el sistema para que después.
Menos 5.9.
No.
Y luego, pero demasiado veces.
Okay, listen. Some of you may have noticed that, for example, you can simplify this if you want to. But no, the idea right now is to see what happens without simplifying. Okay? So if I evaluate, remember that if I want to evaluate is if I need to put this value instead of the x. So 2.9 to the square minus 9, whatever you have over 2.9 minus 3. And that's is 5.9. Okay? The next one will be what? 5.99. The next one will be what? 5.99.
Result is 6.
Aha. If I want to evaluate the 3 directly, what do I have? Doesn't exist. Because if I put this here, it will be 3 to the square 9 minus 9 is 0 over 3 minus 3 is 0. That one doesn't exist, yeah. But what's the tendency? The tendency that is going towards? No. 6. See, check the difference. In this case, observe this. It's 5.9, 5.99, 5.999. The next one will be 5.9. Over 6. This one, no. Sorry, wait. Because in this case, it's going bigger and bigger and bigger. How many what?
How many do we have to evaluate? How many?
No. I'll give you the values directly.
And how's the graph?
Before that, questions about this?
No.
No. In case you're wondering, always the graph for this. Actually, the graph for this is a linear function with a hole. If I were to graph that, just for your information, okay, right now you don't know how to do it, but we'll do it next week then. So, for example, if I want to graph that, the real graph for that actually is a linear function. With a hole. Okay? You may ask, how do I know that? Well, don't worry about that now. We're going to do that next week. I'm going to teach you how to graph this using limits. But right now, don't worry. Okay? Just try to understand this. Okay. Questions? No? Sure? Do you get the idea?
Yes, teacher.
Very good. Take us activities, please. The second one? Yeah.
Teacher, I have a question.
Yeah.
I mean, it's like 2.9.
Yeah. Very right.
And then again. Oh, yeah, because now you have to put in the. Okay, this is the valor de X al cuadrado. Pero this is
You can do it step by step. You can can do the numerator first, have the value, and the subtraction in the denominator, and divide them. If you want to do it in a single step, okay.
Jimena, ¿no viste mi calculadora? Ay, yo no sabía.
Okay, listen. Listen, the activity has two parts. The first 3 pages, I think, something like this. You have tables, you need to fill the tables by evaluating and then tell me the value of the limit. The last page, we're going to do that tomorrow. Okay, the last page will be for tomorrow, what to do in class. But right now, I'm going to do with you some of them. They are a little tricky, so pay attention. Let's try to do the first one first, right now. Here, for example, it says f of x equal to a square root of x as x approaches 0. They're already giving you the values. 0.1, 0.01. Oh. Can I erase this?
Yeah.
Okay. 0.1, 0.01, 0.001, 0.0001, etc. 10 zeros and a 1. Let's do it. How much will be square root of 0.1? Who can help me with that? 0 for what? 0.62? Ah, okay, no, that. Next one? 0.01 square root?
0.1.
0.1. Next one, 0.001. 0.0001. And the last one you have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros and a 1. 10 zeros and a 1.
5 zeros and 3, 1.
Jimena está haciendo 5.
Okay. Do you see a tendency here?
Yes.
So the answer is going to be? 0. 0. Why? Because if you observe 0.3, 0.1, 0.03, 0.01, and the last one is 0.00003. So it's going smaller, smaller, smaller. Towards what? 0. Okay? So in this case it's 0. Get it? Okay. Let's try another one. No, second one already did it. Something similar. No, let's try. Yeah, like that.
Pero profe, la segunda también es 0, pero el second one is also 0.
Second try?
The second one is also 0.
Yeah. Okay, let's try number. Remember logarithmic functions? Ln?
What?
Logarithmic functions?
No.
Well, now let's try to do it. Let's try number 6. Let's try number 6. Okay, now it says ln of x as x approaches infinity. If it says x approaches infinity, that means that I'm going to give values to x as big as possible. For example, 10, 1,000, 10,000, etc. So, for example, here it says ln of x, what will 10? ln of 10, how much is it? In the calculator for that, it's just ln.
Oh, yeah. 2.30.
2.30 what?
35, 85, 32.
32.
30.
No, 2.3.
Yeah, don't worry. 7 factor. 10,000.
9.2103.
And ln of 1 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 23.052.
By infinity, no?
Was it infinity?
Infinity, yes, it is. The limit will be
Was it infinity?
of the infinity. You may wonder yourself, okay, how's it going to infinity if this is just 23? It doesn't matter. It's going, it's growing, growing, and growing. Also, if you don't see it with the values, you can remember the graph. If you remember, the graph for ln the graph for ln is something like this.
Es la contraria del exponencial.
The inverse of exponential goes like that. So this graph, as I go to the right, it's growing, little by little, but it's growing. So it's going towards the infinity. So again, my recommendation is try to study the graphs again, because if you have that, if you have the numbers and the graph, you can understand that better. Okay? Questions? Sure? Okay. One last one. We're going to do number 8. A little tricky. Okay. Let's try doing number 8. This one's a little tricky, so I'll try to go a little slower so you can understand. It says f of x, same place. F of x equal to 1 plus 1 over x to the x power as x approaches infinity. Okay? So how do I do this? How do I evaluate this in my function? Well, for example, the first one. I want to evaluate f of 100. What does that mean? That I'm going to put 100 instead of x. So it's going to be 1 plus 1 over 100 raised to the 100. If I do it step by step, it will be 1 plus 1 over 100 is 0.01. How do I know that? With the calculator. Raised to the 100. This is 1.01 to the 100, and the answer to this, what you said, 2.7
2.70.
48.
2.7 what?
70.
48.
48.
13.
13.
82.
Do we have to put all the decimals?
As much as possible.
Okay.
You'll see what in a moment.
Yes.
1,000?
2.71. 2.71.
Yes, perfect.
2.71. 69. 23. 93. 2. Ya lo hemos hecho.
10,000? Jimena?
¿Cuál? 81.
Again.
By infinity.
45, 92,
41?
45,
45?
92,
92? 7. Okay. 100,000? No, by ninguna.
By 3.
23?
It's going to be 3, right? The answer?
The last one, please.
Or 2.3?
1, 10 zeros. Just try, please. 1, 10 zeros.
81, 82, 81. 81, 8, 28.
Okay. Fine. Listen, please. In this case, those are my answers. Think a little.
2.8, 2.7, 72.
Yeah, chicken
What? If you remember from math 3, this number, the Euler number,
The what?
the Euler number.
¿Cuánto valía el Pero que era el
¿Qué es eso?
Okay, if you forgot, remember that in math 3, at the beginning, at the middle, more or less, you saw exponential functions. One of them was the natural exponential function. To make it short for you, what's pi? Pi. It's a constant, it's a number that is a special number, right? E is another special number. E is another special number. It's a constant, okay? But it's an irrational
que lo
number.
usamos en mover.
Yeah. Yeah. Exactly. Your teacher may have told you that E was like 2.72 approximately. But actually, the real number E is defined by this operation. Okay? That one like that. Yeah? Okay. Excellent. Questions? Yeah.
How do we know it's constant number or E?
That's the idea. This is a special formula.
Okay.
If you apply that limit to infinity for that formula, for that function, you get it. You get it. The other ones are simpler, but this is special. No, in this case, the answer to this are those, and that's fine. But the real answer, the tendency is E. Because normally E will be 2 point blah 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 with more decimals. But to avoid those many decimals,
Para hacer eso, espera.
Ya.
Profe, y si quisieras graficarlo para, pues así como comprobarlo de alguna forma.
Okay, there's a way to graph this. The graph of this is something similar to this rational function, but so at the end, you see the tendency, you'll see that it's going to be If you want to, tomorrow I'll bring you or something else to graph that function, and you'll see the tendency. Esto lo demostró los de pre-AP tercero, pero yo de pre-AP tercero con ustedes, pero así lo hubiéramos hecho. Yo sé. Okay. Good. Questions? No? Okay. So right now, please continue with the activity on your own. Try to finish the other tables.
Ya más. Y sobre 100, o sea, lo que pasa es que dice que
100.
Does that mean you have the one, then you're going to put 2 places. From the point here, 1, 2, 3, and the bottom. That 1, 2, 3.
El examen no me interesa.
Yeah, but not that. Yeah, not that word.
Sí, será. Por eso estaba
Okay, listen please. Before you go. Listen. Listen, please. Okay, please finish this activity except the last.